Hi everyone, welcome back. This tutorial is a follow-up to my previous tutorial on how to organize and present numerical data. In response to a question asked by a student in the comment section of the tutorial, that what if the data values were in decimals? So let's take this question and solve it together. So we have the data on the allergic reaction time to insect stings. Okay. Now the first question says, group the data into 6 classes and obtain a relative frequency distribution. So let's see how to do that. Now when you look at this particular question very well, you will see that they've given us the number of classes, that's 6 classes. Okay. Now since we have the number of classes in the question already, you don't need to find the number of classes again. If you were not given the number of classes, that is when you have to find it yourself using either the Sturgis rule or the 2 exponents k rule I taught you in the other tutorial. But in this particular question, we've been given the number of classes, and that is 6. So for that matter, let me draw a column having 7 rows. Okay. The first row is going to be like that, so let me title it class intervals. So the remaining 6 rows is for this. Okay. Now that we know the number of classes, then let's go ahead and find a class width. Okay. Class width wasn't given in the question. If the class width were also given in the question, you just use it as given. Okay. But class width wasn't given in this question, so we have to find it ourselves. So to find a class width, the formula is h divided by k. H means the highest value in the data set, and then L means the lowest value in the data set. Then K means classes. Okay. So when you look at this data set, what is the highest data value here? So the highest data value is 16.5. Okay. Then what will be the lowest data value? Let's check. The lowest data value will be 3.8. Okay. So we are going to substitute them in this formula. So we are going to have 16.5 minus 3.8 all divided by k. We were given k as 6 in the question. That is the number of classes. Okay. And when you correctly put this on your calculator, you will get 2.1166666 something. Okay. But in 2 decimal places, that will be 2.12. But when you look at the data values, you will see that all the data values are in 1 decimal places. So we can decide to make this to be in 1 decimal place. Okay. And to do that, you are not going to follow the general principle of approximation you already know. You know, generally, if you wanted to approximate this to 1 decimal place, after the first decimal place, okay, after the first one, the next number after the first one, since we want 1 decimal place, if that number is more than 4, we convert it to 1 and add it to this, right? But if that number is 4 or less, you ignore it. So if you wanted to follow the general principle of approximation, this 2.12 in decimal place should have been 2.1, isn't it? But you are not going to follow that principle here, okay? In this particular topic, the class width, okay, don't follow that principle. You have to run it up, okay? So we want to run it to 1 decimal place, so we run it to 2.2, okay, not 2.1. Now we know the class width to be 2.2, okay? So let's see how to treat it. Now we are going to create the lower and the upper class intervals or class limits. Okay. To do that, you can choose to take the lowest value in the data set. Okay. Or a value which is a bit lower than the lowest value, like 3.7 or 3.6. Okay. But I want to use 3.8. I want to start with 3.8. Okay. So let me start with 3.8. So I'll just write it here. You can choose to also start with 3.7 or 3.6, okay, but I want to start with 3.8. Is that okay? Now, after writing the lower class limit of the first class, this is what you do. You take the class width, which is the 2.2. Now, when you add 2.2 to 3.8, you get 6.0, isn't it? So that 6.0, you are going to write it as the lower class limit of the second class. So we write 6.0 here. So when we add 2.2 to 6.0, we get what? 8.2. Add 2.2 to 8.2, you get what? 10.4. Add 2.2 to 10.4, you get 12.6. Then add 2.2, you get what? 14.8. You see that? So after getting the lower class limit for each class, then we put some dash here. Okay, it means 2. Okay, TO, 2. There are several ways you can get the upper class limit of each class. Okay, there are several ways you can do that, but you look at this. Okay, now since our class width is in one decimal place, let's subtract 0.1. Okay, from this 2.2, just 0.1. Let's subtract 0.1 from this. What do we get? We'll get 2.1, isn't it? 2.1. Add it to it. When you add it to it, what do you get? You get 5.9, isn't it? So we write up 5.9 here. Is that okay? You can subtract 0.1 from this 6.0. You still get this 5.9. Okay. So after getting the first upper class interval of the first class, then we'll find the rest. To find the rest, the same 2.1 you added to this 3.8, you can add 2 also to get the upper of this place also. The same 2.1 you add it to this place to get the upper of this place also. That same 2.1 you add it to this to get the upper here. That same 2.1 you add it to this to get the upper here. Then that same 2.1 you add it to 14.8 to get the upper here. That is one way you can do it. Another way is, you see, I've gotten this 5.9 already, right? I can choose to be adding the 2.2 how I did for the lower class intervals. So when I add 2.2 to 5.9, I will get what? 8.1. And the same way, when you add 2.1 to this 6.0, you still get the same 8.1. You see that? So you can choose to do it either way, okay? But let me add 2.2 to this 8.1, I'll get what? 10.3. If you add 2.1 to this 8.2, you still get the same 10.3, okay? Then let me add 2.2 to this 10.3, I'll get what? 12.5. And let's add 2.2, I'll get 14.7. Then we add 2.2 to 14.7, we'll get 16.9, okay? So make sure that all your data values fall within all the classes. When you look at the upper class interval of the last class, it's 16.9. When you look at the lower of the first class, it's 3.8. If all your data values can't fall within that range, let's assume this last one happened to be 16.4. And you know your highest data value, 16.5, can fall within. Since the last year is 16.4, it means you have to shift this back a bit. Maybe you have to start from 3.7 or 3.6 so that all can fall within. You get it? So that's how to get the class intervals. Let's title the table, okay? Let me title a relative frequency distribution of reaction times of these things, okay? Now let's create a tally. So let me add extra column. Let's title this column tally, okay? We are going to be cancelling them one by one and be marking them in their various classes, okay? So the first one is 5.9. So let's cancel 5.9. Now 5.9, where will it fall? It will be in the first class. You see, the first class is 3.8 to 5.9. So we mark 1 here. You see that? Then we cancel this and then go and mark it where it will fall. It will be in this class, the fourth class. So we mark 1. Then 9.9 will be, so we mark 1. 14.4.4, it will be in this class. Okay, the fifth class. So we mark 1. Then 16.5 will be in the last class. Okay, the last class is 14.8 to 16.9. So 16.5 will be there. Then 12.7. 12.7 will fall here. Then 11.6. 11.6 will be in the fourth class. Then 7.9. 7.9 will be in the second class. Then 10.9. 10.9 will be in the fourth class also. Then 13.4. 13.4 will be in the fifth class. Then 8.6. 8.6 will be in this class. Then 11.7. 11.7 will be in this class. This particular class here, that's the fourth class. Then 12.5. 12.5 will also be in this class. Okay, but it's going to be the fifth one we will be taking. So for the fifth one, you have to use it to cross the previous 4. Okay, that's how you do it. Then 9.1. 9.1 is going to be in the third class. Then another 9.1, it will also be in the third class. Then 12.2, 12.2 will be in the fourth class. Then 11.5, 11.5 will also be in the fourth class. 7.4, 7.4 will be in the second class. Then 8.8, 8.8 will be in the third class. Okay, but it will be the fifth one, so we have to cross with it. Then 11.5, 11.5 is going to be here. Then 13.6, 13.6 is going to be in this class. Then 11.5, 11.5 is to be in this class. Then 10.9, 10.9 is going to be in the fourth class also. It will be the fifth one in this case also. Like that's the 10th one, but we have 4 lines already, so we have to cross it. Okay. So 12.9, 12.9 is going to be here. That will be the fifth one, so let's use it to cross. Then 11.2, 11.2 also be here. Then 15.0, 15.0, 12.7, 12.7 will be in the fifth class. 10.1, 10.1 will be in the third class. 10.7, 14.7 will be in the fifth class. Then 9.9, 9.9 will be in the third class. Then 11.4, 11.4 will be in the let me see, yeah, that's going to be the fourth class. Then 6.2, 6.2 will be in the second class. Then 8.3, 8.3 will be in the third class. Then 8.1 will be in the second class. Then 10.0, 10.0 will be 10.0, no, 10.5 rather. It will be in the fourth class. Then 8.4, 8.4 will be in the third class. Then 11.2, 11.2 will be in this class. Okay, that's the fourth class. Then 10.4, 10.4 will be in the fourth class. That's the fifth one of this series. Okay, so we cross with it. Okay, then 9.8, 9.8 will be in this class also, and will be the fifth one of this series. Okay, so we cross with it. So that's how to get a tally. Then let's write the frequency. So let me add extra column. Then let me title it frequency. So we are going to count. So 1, 2. So the first frequency is 2. We'll count this 1, 2, 3, 4. So 4. Then this is 5. This is also 5. That makes it 10. So 10. 5, 5, 5. 15. So 15. 5, 6, 7. So 7. 1, 2, 2. And the total frequency will be 2 plus 4 is 6, plus 10, 10, plus 15, that's 31, plus 7, 38, plus 2, 40. So the total frequency is 40, okay. Now, we are going to create relative frequency. Since the question says we should obtain a relative frequency distribution. If the question was just frequency distribution, there wouldn't be much problem if you don't create the relative frequency. Okay, so let's add extra column and then let's title this place relative frequency. Okay, now to find relative frequency, see the frequency of a particular class divided by the total frequency. So for this first class, if we want to get a relative frequency, we will take the frequency of this first class, which is divided by the total frequency, which is 40. So we're going to have 2 over 40, and that will give us 0.05. Then for the second class, 4 divided by 40 will give us 1 over 3. Then for the next class, 10 divided by 40 will give us 1 over 4. That's 0.25 in decimals. Okay. Then 15 divided by 40 will give us 0.375. Then 7 divided by 40 will give us 0.175. Then 2 divided by 40 will give us 0.05. So when you add all together, you must get 1, provided your approximations are correct. Okay, please, the approximation I taught you for the class with, don't use it in this case. So this time around, you have to follow the original rule of approximation, the original one. You have to follow it in this case. So the approximation I taught you under class with, take it that it applies to only that situation. Okay. So let's go back to the question again. Question B says, draw a histogram for the distribution and use it to find the mode. So let's see how to do that. Let's go back to the table. Now if you want to draw a histogram, you will need the class boundaries and the frequency. You can also use the relative frequency in place of the frequency, okay? But let's say we will need the class boundaries and the frequency. So let's find the class boundaries. So let's add extra column. Then let's title this place class boundaries. Now, to find class boundary, this is how we do it. We need some value to deduct from the lower class interval and add to the upper class interval to get the lower class boundary and the upper class boundary. Okay. And that value, we are going to call it class boundaries adjustment or class boundaries correction. Okay. How do we find that value? To find that value, we can take the lower class interval of the second class, okay, this 6.0, minus the upper class boundary of the first class and divide the result by 2. This is what I mean. 6.0 minus 5.9 all divided by 2. So 6.0 minus 5.9 will give you 0.1. Divide by 2 will give you 0.05. Not 0.5. Rather, 0.05. Be very careful. Okay. 0.05. So this 0.05 is the class boundaries adjustment or class boundaries correction. Okay. If you take 8.2 minus 8.1 divided by 2, you still get the same 0.05. Okay. Now, this 0.05, we are going to be robbing it from Peter to pay Paul, as I always say. That the lower class is Peter and the upper class is Paul. Okay. So let's deduct the 0.05 from Peter, which is 3.8. When we deduct, we'll get what? 3.75. Then let's add it to Paul, which is 5.9. And that will give us what? So before that, we put a dash here. So we add, that means 2. Okay, TO2. So we add the 0.05 to 5.9. So that will give us 5.95. So we go to the second class and do the same. 6.0 minus 0.05 will give us what? 5.9. So when we add it to this, it will give us what? 8.15. 8.2 minus 0.05 will give us what? 8.15. 2. 10.3 plus 0.05 will give us 10.35. Then 10.4 minus 0.05 will give us 10.35. 2. 12.5 plus 0.05 will give us 12.55. Then 12.6 minus 0.05 will give us 12.552. 14.7 plus 0.05 will give us 14.75. Then 14.8 minus 0.05 will give us what? 14.75. To 16.9 plus 0.05 will give us 16.95. So that's how to get the class boundaries. And when you look at the class boundaries, you will see that the upper class boundary of the first class is the lower class boundary of the second. And the upper class boundary of the second class is the lower class boundary of the third class. The upper here is the lower here. The upper here is the lower here. You see that? So let's see how to draw the histogram. So let's take our graph sheet. Let's draw the y-axis. Let me put some arrow at the top here. Let's do the x-axis also and put some arrow here. Okay. Let me label this place class boundaries of reaction time. Okay. And then let me put frequency here. Then let me title it histogram of reaction times of these things. Okay. Now when you check the frequency table, the highest frequency is 15, isn't it? So we have to make sure we get up to 15 and more. Okay. So let me check if my line should be up to, if I should make this whole box 1. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Mine will be up to 15. If it's not up to, it means you shouldn't make it 1, 2. You should make it something like 2, 4, 6, something that way. But mine will be up to. So the origin is always 0. So let me put 0 at the origin. Okay. Then this place will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then we are going to put the class boundaries at the x-axis. So this is how we do it. When you look at the first class is 3.75 to 5.95, isn't it? So I'll label this first place 3.75. Then the next one will be 5.95. You see that? Now, when you look at the next class is 5.95 to 8.15. But we have 5.95 already. So we just have to do the upper. That will be 8.15. Then the next class is 8.15 to 10.35. 15. So we just write the 10.35. You get it? Then the next class is 10.35 to 12.55. So we already have the 10.35. So we just write 12.55. The next class is 12.55 to 14.75. Since we have 12.55 already, then we just write 14.75. And the next one is 14.75 to 16.95. And then since we have 14.75 already, we just write 16.95. You get it? Now, the first class, which is 3.75 to 5.95, what's the frequency of that class? The frequency of that class is 2. So we are going to draw a bar up to the height of 2. Okay, so we draw a bar to the height of 2. That's basically it. Then we just shade inside. Okay. Then we go to the next class. The next class is 5.95 to 8.15. And what's the frequency of that class? The frequency of that class is 4. Okay. So we draw up to 4. So we just shade inside. So you see that in histogram, no space. Okay. Then we go to the next one. 8.15 to 10.35. What's the frequency of this class? The frequency of this class is 10. So we are going to draw the line up to 10. Okay. So you shade inside. Now 10.35 to 12.55. The frequency of that class is what? 15. So we draw the bar to the height of 15. Okay. So we shade it also. Then we go to the next one. The next one, which is 12.55 to 14.75. The frequency of this class is 7. So we draw the bar up to the height of 7. So we shade inside also. So we go to the last one, 14.75 to 16.95. The frequency of that class is 2. So we draw it up to the height of 2. And then we shade inside also. So that's how to draw histogram. But the question says we should use our histogram to estimate the mode. Now, to do that, we are going to use a particular one. Okay. So this is what you do. For the highest one, you stand at the edge here. Okay, this edge. And then you draw a diagonal line from this edge to come and touch the edge of the next bar. Okay, so we just do that. You see that? Then we do it for this side also. We draw a diagonal line from this edge to the edge of this one, a tip here. Okay, so you just draw it that way. So the point of intersection of these two lines, okay, is intersect. They intersect on this particular line. So I'm going to trace it down to the x-axis. Okay, so I'll just trace it down to the x-axis. Okay, so where to fall on your x-axis, you will read that. When I read mine is 11.23. Okay, you use pencil for everything here. Okay, I wanted you to see this one clearly. That's why I use red. Okay, so let's go to the next question. Question C. Plot the cumulative frequency curve. Use it to estimate percentage of patients who have experienced a reaction within 10 minutes and the median. So to do that, let's go back to our table. Now to construct a cumulative frequency curve, we will need the upper class boundaries and the cumulative frequency itself. So let's add extra column and let's title it cumulative frequency. Now to find cumulative frequency for the first class, the cumulative frequency of the first class will be the same as the frequency of the first class, so that will be 2. Okay. Then the cumulative frequency of the second class will be the first plus the second to get a cumulative of the second. So 2 plus 4 will give us what? 6. Then to get a cumulative frequency of the third class, it should be the frequency of the first plus second plus third. So that will give us what? 16. Then to get a cumulative frequency of the fourth class, it should be the first plus second plus third plus fourth. That will give us what? 31. Then to get the cumulative frequency of the fifth class, it will be first, second, third, fourth, fifth. When we add them together, we get what? 38. Then to get the cumulative frequency of the last class, we add the frequency from the first to the last class, and that will give us what? 40. The cumulative frequency of the last class must be the same as the total frequency. Now, as I said, we'll be using the cumulative frequency and the upper class boundaries of each class. Okay, so we'll be plotting the upper class boundary of each class against the cumulative frequency. There's something. You see the lower class boundary of the first class, the 3.75. We are going to plot it against 0. Okay, against a cumulative frequency of 0. Before we start plotting the upper class boundaries against their various cumulative frequencies. Okay, there's a reason to this being plotted against 0, but I don't want to explain that now because we've learned a lot already. So let's take our graph sheet. So let's draw our x and y axis as usual. I wanted to write reaction time less than. At the cumulative frequency side, the highest cumulative frequency is 40, so I should be able to plot something that should be up to 40. So I can use something like 5, 10, 15, 20, 25, 30, you get it, as at the y side. Okay, so let me start from the origin. Let me title the chart first. So the origin is going to be 0. Then in this place, let me make it 5, 10, 15, 20, 25, 30, 40, 45, 50. Now, at the x-axis, this is what we are going to plot at the x-axis. First, we are going to write the lower class boundary of the first class, which is 3.75. Okay. Then we write the upper class boundary of the first class, which is what? 5.95. Then we write the upper class boundary of the second class, which is 8.15. Then we write for the next class, which is 10.35. The next class will be 12.55. The next class will be 14.75. And the last class will be 16.95. Okay. As I said, we'll be plotting each upper class boundary, okay, against their various cumulative frequency. But I'm going to start from this one and plot it against 0. That's the lower class boundary of the first class. Okay. Then the upper class boundary of the first class, we'll plot it against its cumulative frequency, which is what? 2. So 2 will be here. Okay. Then the upper class boundary of the second class is 8.15. We'll plot it against the cumulative frequency of the second class, which is 6. Okay. Then the upper class boundary of the third class is 10.35. We'll plot it against the cumulative frequency of the third class, which is 16. So we plot it here. Then the upper class boundary of the fourth class is 12.55. So we'll plot it against the cumulative frequency of the fourth class, which is 31. So we plot it here. Okay. Then the upper class boundary of the fifth class is 14.75. So we'll plot it against the cumulative frequency of the fifth class, which is 38. So 38 will be here. Then the upper class boundary of the last class is 16.95. So we'll plot it against the cumulative frequency of the last class, which is what? 40. So let's draw a curve to pass through the points. Okay. So we start from here and then draw up to this point, then move to the next point, then move to the next point, then move to the next point, then we move to the next point, then we move to the last point. So this is the cumulative frequency curve. But we are not done. Let's go back to the question again. The question says, after plotting the cumulative frequency curve, we should use it to estimate percentage of patients who have experienced a reaction within 10 minutes and the median. So to do that, let's go back to our graph sheet. Now, since the question says within the first 10 minutes, so we are going to locate a reaction time of 10 minutes on the x-axis. Okay. So how do we locate a reaction time of 10? Now you have to do the estimation yourself. But one strategy is, if you can know the width of each of the small boxes, okay. You see, from this thick line to this thick line, there are 10 small boxes within. Okay, 10. So to know the width of each of the small boxes, we can take this 10.35 minus 8.15. We'll get 2.2, and we'll divide it by 10 boxes, by 10. So that will give us 0.22. So that means each of the small boxes is 0.22. So you can find a way to know where 10 will fall, okay? For me, I've noticed that this middle tick line between them will be 9.25, okay? So since I noticed that this will be 9.25, then I'll just read. So I was able to read it up, and I realized that my 10 will be around this place, okay? So I'll just trace from where I've been able to locate to the 10. I'll trace that place up to the curve. You see, this is where I've been able to locate to be my 10. Okay, if this place is 9.25, each of the small boxes is 0.22. So find a way to add them until you get up to 10. So I know my 10 will be here. The 10.35 is this thick line, okay, but my 10 will be here. So when I trace it up to the curve, where it will intersect the curve or where it will touch the curve, you trace it from that place also to the y-axis, okay, where it will intersect with the curve. I don't think I've done it well, but you try and do it well. Where it will intersect with the curve, you trace it from that point of intersection to the y-axis. So it falls on what? It will be like 14 point something, 14.8 or something. But let me assume it to be 15. Let me just assume it to be 15. So if I want to answer that question, to find a percentage that fall within 10 minutes, okay, I'll just take this 15, and divide it by the total frequency of 40 and multiply it by 100. So 15 over 40 will give me 0.375. When I multiply 0.375 by 100, it will give me 37.5%. So that's the percentage of patients whose reaction fall within 10 minutes, okay. Then the second question says we should find a median. So to get a median, we'll come and focus on the frequency side. The total frequency was 40, you remember. When we divide the total frequency of 40 by 2, it will give us 20, isn't it? So you come to where 20 is on your, then you trace it from this 20, since half of 40, half of the total frequency is 20, right? So we trace it from this 20 to the curve, okay? So we trace it to the curve. Where it will intersect with the curve, the intersection, we will trace the point of intersection down to the x-axis. So let's trace the point of intersection down to the x-axis. I don't think I've done it perfectly, but please try and do it perfect, okay? Now, what will it correspond to? Okay, what time will it correspond to? Now, this tick box is 10.35, right? And each small box is 0.22, right? So I have 1, 2, 3. I have 3 small boxes before the line. So these 3 small boxes, what is their width? 0.22 times 3, that's 0.66. So their width is 0.66. So if I add 0.66 to 10.35, I'll get what this place will be. So that will be 11.01. So the median reaction time is 11.01. Okay. We'll be solving more questions as time goes on. So it is important to like this video, share it, and also subscribe to the channel. Thank you.